All right, AGS1. Since we have an asynchronous day today, I thought I'd make a second video that's specifically to help you with the Go formative, because I realize that the closure notes are awesome, but they're some pretty big, broad concepts without much specifics. So I'm going to do 2 of the 4 problems on your Go formative for you. So you should be able to get halfway through it just by following this video. So the first problem they give you is they give you this this graph here that's like this step little zigzaggy thing, and then they ask you about like domain range and certain inputs and outputs. So the domain, you guys, you see how these arrows go forever that way and forever this way? That means that this graph is going to keep expanding forever this way and forever this way in terms of the x's. So the domain is going to be all real numbers. But the way we write that in interval notation is open parentheses, negative infinity, all the way up to positive infinity, close parentheses. Using the parentheses instead of the brackets because you can never truly get to infinity, so you can't include it. The range is very similar because these arrows keep going forever up and forever down, as well as forever left and right. So these are going to keep getting bigger this way and this way for the range. Sorry, I don't want to clutter up the drawing. So the range is also negative infinity to positive infinity. The next question asks, what is f of 4? Which means this 4 is an input, an x. So if I go to the graph and I count 1, 2, 3, 4, at this point right here, the output is 0 because it's on the x-axis. So that's the coordinate 0, 4, which means if you put in it's the coordinate 4, 0, which means if you put in a 4, you get out a 0. So this is 0. The next question says, what x would you put in to get an output of 4? So we need to count up on the y-axis, 1, 2, 3, 4, and then see where the graph touches this line of y equals 4. It touches right here at the coordinate 1, 4, which means you need to put a 1 in to get a 4 out. So the answer is 1. 3 more things we're going to do with this graph. The y-intercept is wherever it touches the y-axis, which is right here at 1, 2, 3, so 0, 3. That's a coordinate, not an interval. The local maximum is going to be the top of this mountain right here, so that's going to be 1, 4. And then the local minimum is the bottom of this valley, which is 1, 2, 2, -2. 2 over and 2 down. So those are all coordinates. Next up, I think this is the second or third problem in the Go formative. So they already told us the domain goes from -4 to 3, which does make sense because I see a -4 here and I see a 3 here. So that's how far it went on the x-axis. Now the range, the top of the range, if I go over to the y-axis, is going to be 3, and then the bottom of the range is going to be 1. Sorry, those numbers are super small, but if you zoom in on the picture, those are the right ones. So what did I say? It's going to be -1 to +3, including -1 and including +3. That's from here all the way up to here. That's as much, all the y-axis that the graph touches. Key features. They tell us that the y-intercept is at 0, -1, which makes sense. That is 0, -1. List 2 more. Well, how about x-intercepts? I see an x-intercept here and an x-intercept here. So that is the point -1, 0, and that's 1, 0. So I'm going to say x-intercepts are -1, 0 and 1, 0. Now the function notation. This part right here says that if I put in a -3, I should get out a +2. Let's make sure that makes sense. So if I put in a -3 and then go up to the line, yeah, that is positive 2. So that checks out. Now, f of 0, that means putting a 0 in terms of x. That means the output would be where it touches the curve down there, which is -1. This last one says, what would you put in to get an output of 3? So if you go up to 3 on the y-axis and trace it over, that means -2 is what you would put in. So, -2. Okay, you guys, shoot me an email if you have trouble